The early Greeks watched the sky very closely. Greek farmers used the positions of the sun and stars to plan and organize agricultural chores for each season. Greek sailors used the stars to guide their navigation. The Greeks' main contribution to astronomy, however, was their effort to explain what they saw. They did more than merely observe and record the movements of the heavenly bodies. They sought to understand why and how those bodies moved in such an orderly and predictable way. In doing so, the Greeks transformed stargazing into a science. Greek astronomers spent little time wondering about what the planets were made of or how they came into existence. Instead, they wanted to find a logical, orderly system for predicting the movements of the sun, moon, and planets. They looked to mathematics and geometry to help discover such a system. Prior to the Greeks, rewind about 10,000 years to the time of the first civilizations, and the earliest astronomers who already figured out how to use the sky. In some cultures, they were priests, priestesses, and other elites who studied the movement of celestial bodies to determine rituals, celebrations, and planting cycles. With their ability to observe and even forecast celestial events, these people held great power among their societies. This is because the sky remained a mystery to most people, and in many cases, cultures put their deities in the sky. While astrology was still a religious practice for the early Greek astronomers who used their mathematical and mapping skills to read horoscopes, at around 357 BC. With the rise of the Christian Church, it quickly fell off, due to the fact that astrology was considered pagan magic and punishable by death. Thus, the early Greek astronomers focused more on the scientific side of the study. But because of the way Greek astronomers used the scientific ways of viewing the sky, they debunked the beliefs like the sun revolving around the earth, the flat earth theory, and the earth being the center of the universe, while also making many historic new discoveries. Since astronomy as a scientific study was very new, these astronomers had very little astronomical tools besides their eyes, written star charts, and very basic instruments like sundials. But even with these limitations, these Greek astronomers made discoveries and shaped the way we view the universe. So, who were these men? The year is 500 BC. Pythagoras, a philosopher better known for mathematics, also contributed to the knowledge of the Greek philosophers by postulating that the earth was spherical. Famously, he proposed this idea because he noticed that ships disappear below the horizon when they sail away, implying that the surface of the earth is curved. He also proposed that, if the moon and other celestial bodies were spherical, then it made sense that the earth would be too. Pythagoras saw spheres as the perfect shape. Pythagoras was the first ancient astronomer to suggest that there was a harmony of the spheres, and that the movement of the planets, sun, moon and stars could be described by whole numbers and mathematical precision. His other discovery was that the morning and evening star are the same thing, the planet Venus. These discoveries were positive for science, but had both negative and positive impacts on Pythagoras. His mathematical ways of figuring out the universe made some people believe he was sent from the heavens, on which he grew a following, but others saw the following as a cult, and chased him out of town, while burning down his house. Our next great Greek astronomer, born after Pythagoras, in 310 BC was Aristarchus. He managed to place the sun in the middle of the solar system, and he also placed the planets in the right order from the sun. He gave a model of the universe with a stationary sun and planets rotating in circular orbits around the sun. The stars, which are actually stationary, seem to be rotating because the Earth rotates on its own axis. Aristarchus was one of the first astronomers to calculate the relative sizes of the sun, the moon and the Earth. He did this by observing the moon during a lunar eclipse and by estimating the angle and the size of the Earth. He understood that the sun, the moon and the Earth form a near right angle during the last and the first quarter of the moon. Based on this, he calculated that the sun was 19 times further away from Earth than the moon. However, he made a mistake in his calculations. He took the angle as 87 degrees while the correct angle is 89 degrees 50. Thus, the actual distance is 390 times and not 19 times, as proposed by Aristarchus. Although the geometric theory is current, the calculations were wrong due to lack of precise instruments rather than logic. His theory that the diameters of the Moon and the Sun should be proportional to their distance from the Earth is also logical but gave wrong results. Today that the intelligence of Aristarchus and his contribution to science has been renowned, scientists have given his name to a crater on the Moon. His discoveries still feed into modern science to this day, but just like Pythagoras, he was ridiculed for his beliefs his whole life. Nextly is one of the most famous and respected Greek philosophers. In the early 200s BC, Aristotle was one of the first to recognize that the Earth was a sphere, believing it was being pulled into its center by some force. He came to this conclusion by noticing the shadow cast on the Moon during an eclipse. He also proclaimed that all celestial bodies in solar system followed a circular path. But not all of Aristotle's astronomical claims were right. Aristotle would go on to create works on the geocentric universe that would secure its place as the predominant cosmological theory. According to Aristotle, the Earth was the stationary center of the universe. The stars and planets were carried around the Earth on spheres or circles, arranged in the order of distance from the center. These were the Moon, the Sun, Venus, Mercury, Mars, Jupiter, Saturn, fixed stars, and the fixed stars. Although not right, because Aristotle was such a respected observer at the time, no one challenged these claims until the Renaissance period, and even accepted as biblical by the Catholic Church. Our next astronomer was one of the best observers and mathematicians around the late 200s BC. He is best known for being the first person to calculate the true circumference of the Earth, which he did by comparing angles of the midday sun on a stick's shadow, at two places a known north-south distance apart. Then using the angle, he calculated the rest of the sphere. His calculation was remarkably accurate. He was also the first to calculate the tilt of the Earth's axis, again with remarkable accuracy. Additionally, he may have accurately calculated the distance from the Earth to the Sun and invented the leap day. He created the first map of the world, incorporating parallels and meridians based on the available geographic knowledge of his era. His knowledge was so highly regarded, he was given the role of director of Alexandrian Library, by the third king of Egypt. Our final astronomer is known as the greatest Greek astronomer and the inventor of trigonometry. His name is Hipparchus. He was born in 190 BC. He was a builder of excellent instruments to measure positions of stars, which led to excellent star catalogues, and extensive tables of the Sun, Moon, and planet positions, that predicted eclipses, including solar ones, along with their time and places. This was very hard to do. Next, Hipparchus hypothesized that the fixed stars might actually move, then devised a method to check this over centuries. Hipparchus also measured length of year with an error estimate of only 6 minutes. But his greatest discovery was precession, which is a gravity-induced, slow, and continuous change in the orientation of an astronomical body's rotational axis. In particular, it can refer to the gradual shift in the orientation of Earth's axis. This was behind the cosmos, created by Garrison Rice and Le Corsac.